Hey guys, it's Dr. Brown with Kubo Math, and tonight it's 5th grade math. So we're looking at estimation and then some exponentials here, some exponents. So let's get after it. Okay, we have a problem here. If I can get wrapped around my cord. We're talking about estimations. And in this case, they wanted you to take just a quick estimate of what the sum of these two numbers might be. Now they wanted to round to the nearest thousand. So ones, tens, hundreds, thousand. So they're looking at this digit and this digit, and they're looking then to the right of that at this number. If that number is less than 5, they keep the 8, they bring that same number down, make everything else 0. So in this case, this number would turn out to be 8,000. This number, I want to look at the 2, or adjust the 2 up or down, but I look to the number to the right of it. If it's 5 or greater, I add 1 to this number, so 2 plus 1 is 3. Make everything else 0. So I have 8,000 plus 3,000 equals 11,000. That's estimate, okay? Now, if you think about, let's just look at this 8182. All it's saying, we're looking at this and trying to figure out to the nearest thousand what the number is. So it's 8182. So this is 8,500 here in the middle. Is this 8182, is it closer to 8,000 or closer to 9,000? It's closest to 8,000. So we just make it 8,000. That's our estimate. 2724, let's look at that one. Okay, so we have 2,000 and 3,000. And we have 2,500 in the middle. So it's saying 2724. So it's somewhere in here. That's 2724. Is it closer to 3 or closer to 2? It's closer to 3. So we estimate it's 3,000. And that's where that comes from. Okay, but they do have the rule. You look at the number you want to adjust, look to its right. If it's 5 or greater, add 1 and make everything else 0. So 2 plus 1 is 3. Okay, so let's look at this one. We're trying to adjust on the thousands. Okay, so we look to the right. That number is 7. It's greater than 5 or greater. So we add 1 to 6, which is 7. Everything else goes to 0. This one, I look to the right. It's less than 5. I keep the 1 and make everything else 0. So 7,000 minus 1,000 equals 6,000. Okay, so that would be estimation of adding and subtracting. Now what about multiplying? Okay, this problem says, let's take a look at these and adjust those on the tens and then multiply 2 of those numbers together. That will give me a number somewhere between 350 and 450. So if I'm looking at the adjusting on the tens, this is ones, tens. So this is a 1. Look to the right. It's less than 5. So I keep the 1, make the other number a 0. So I'm wanting to adjust on the 10. Look to the right. It's greater, 5 or greater. So it is. So I add 1 to 4, which is 5. Make the other number 0. So what do you think about this one? Okay. At 3, I want to adjust on the 3. I look to the right. It's 9, so it's 5 or greater. So add 1. 3 plus 1 is 4. Make the other number 0. So this one, 1, look to the right, it's 9, 5 or greater, so I add 1 plus 1 is 2, make the other number a 0. So now I have 10, 50, 40, and 20. The question is, if I what two numbers can I multiply together to give me the product that's between 350 and 450? Well, 10 times 50 is 500. Whoops, that number is over here. Well, 50 times 20 is 1,000. Whoa, okay, that number's way over here. 10 times 40, hey, there we go, that's 400. That number would be right here. So 10 times 40 would give me 400, and that's an estimate of a quick way to multiply those to see about which numbers may work. So that's how estimation works. So let's erase all of this. And the board is very humid in the room here. And we're going to give ourselves a workspace to work these 5 problems. So we're looking at some exponents and less than, greater than problems, and trying to understand if we can solve these based on what they're asking for. Okay, let's look at number 1. This number, the number is 6 more than 2 to the 5th power. The number that we're looking for is 6 more than 2 to the 5th. Let's let the number we're looking for, we're going to give it a name. Okay, instead of the number, we're going to call it A. A. That's the number we're looking for. It could be B, C, O, Q, but I actually like X. But since you use the multiplication sign with the X, it might be confusing. So let's call it A. Okay, they're saying A is 6 more than 2 to the 5th. So 2 to the 5th plus 6. 6 more than 2 to the 5th. More would be adding, right? Wow, what's 2 to the 5th? Well, that equals 2 times 2, or times itself 5 times. 2 times 2 times 2. 1, 2, 3, 4, 5. Okay, that's 2 to the 5th plus 6. Please excuse my dear Aunt Sally, the order of operation. Parentheses would be first, right? If we didn't have, I put that on here, but if I hadn't, there's no parentheses on this, but there is an exponent. Please excuse exponents. So the order of operation, please excuse my dear Aunt Sally. Parentheses, exponents, multiply, divide, add, subtract. That's the mathematical order of operation. But in the U.S., they taught us that's please excuse my dear Aunt Sally. And that allowed us some way to always remember the order of operation. Okay, let's figure out what we have here. A equals this. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So A equals 32 plus 6. A equals 38. Wow. Okay, that one is 38. All right, one down. We are rolling. And I have a sticky board here. All right, the second question, number 2. Now I didn't write that we're looking for the number, but just know the number is 16 less than 8 to the 3rd. What's our number? A. A is 16 less than 8 to the 3rd. Is 16 less than 8 to the third. This number is 16 less than 8 to the third. Well, what's 8 to the third? I don't know offhand. 8 times 8 is 64. 64 times 8. 8 times 4 is 32. Carry the 3. 8 times 6 is 48. 49, 50, 51. 5, 12. 8 times 4, 32. 8 is 48. 49, 50, 51. So 512. And it's 16 less. So this is 512 minus 16. 6 from 2 is 6. I have to borrow 1, which gives me a 0. 1 from 0, I have to borrow 1 from this guy, leaves me 4. So 1 from 10 is 9. And then bring the 4 down, 496. So A equals 496. Okay? 496. All right. Now then, the number that we're looking for is greater than 2 to the 5th. So we're looking for some number, but it's greater than 2 to the 5th, but it's less than 2 to the 6th. So my number I'm going to put in here, but it's less than 2 to the 6th, and it's a power of 7. So the number I'm looking for, A, is a power of 7. So mathematically, that's what those words are telling me. And that becomes very important. You read it, and as you read, try to not go, oh, okay? Back up from that and just say, and also don't say, oh, I'm going to figure that in my head, and then get the wrong answer and have no clue about how you got there. So just relax and say, what is that telling me mathematically? Okay, my number I'm looking for is greater than 2 to the 5th, less than 2 to the 6th, and it's a power of 7. Okay, 2 to the 5th. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, and that's less than 7 to the A. So if 2 to the 5th is 32, times 2 would be 2 to the 6th, which would be 64. Okay, now then, when it says A is a power, what does that mean? Well, what are the powers? 1, 2, 3, 4. Okay, well, we can say, 7 to the 1 is 7 times itself 1 times, which is just 7. It's a bad looking 7. Okay, 7 to the 2nd power. That's 7 times 7. That's 49. Oh, 49. 49 is greater than 32 and less than 64. So 7 to the 2nd power. So 7 to the 2nd power is greater than 32 and less than 64. So the number I'm looking for that's a power is 2. So the number that I'm looking for actually was 49, which was 7 to the 2nd power. Okay. Let's see if I can get some of this off of here. All right. Now then, the number that we're looking for is greater than 13 to the 2nd power, but it's less than 6 to the 3rd power. Oh, and it's an odd number, and it can be divided evenly by 15. Okay, so it's greater than 13 to the 2nd power, but it's less than 6 to the third power. So I've got A in here. But A is an odd number. A is odd. And I can divide it evenly by 15. So A by 15, it goes in with no remainder, is what they're saying. But it's an odd number. Okay? Well, first, what's 13 times 13? 3 times 3 is 9. 3 times 1 is 3. Bring down the 0. 1 times 3 is 3. 1 times 1 is 1. 9 plus 0 is 9. 3 plus 3 is 6. So I have 169. So I have 169 is less than this number. And then A is less than 6 to the third power. Well, 6 times 6 is 36. 36 times 6 would give me 6 to the third. 6 times 6 is 36. Carry the 3. 6 times 3 is 18, 19, 20, 21. 216. Well, what to do now? All right, well, we just earlier talked about estimation. Okay? Estimating. Well, this number can be divided evenly by 15. So that means 15 times some number, something, gives me the number I'm looking for. Well, what's an estimation of 15 times 10? That's 150. Okay? So 15 times 10 equals 150. Well, my number has to be odd. This is even. Well, what is 15 times 1? Because that would be, if I add those together, now that's 11. So 15 times 1 is 15. So what does that come out to be? 165. Oh, we are so close. Now you may be tempted to say, oh, well this is 11 times 15, gives me 165. I'll just make it 12. And that'll go in there, but the number has to be odd. Okay, it can't be 12. It would maybe 13. Well, 15 times 2 more, so that's 10, 11, 12, 13. Well, 15 times 2 is 30. Now then, I'm looking at 150 plus 45, which gives me 195. So this, which is in between, so A is 195, which is 15 times 13. So 169 is less than 195, which is less than 216, but this was, the two numbers were 15 times 13. Okay, and that, obviously, that's an odd number. And we knew we had to have odd times odd to end up with odd. Okay, keep that in mind. All right, so that was 15 times 13 equals 195. All right, the last one here. We started on this one today and didn't get to finish. So I'm going to work this one out for my buddy. And we'll see. I don't think we were reading this one correct earlier. Okay, we're looking for the number that's greater than 8 times 5 to the third. Okay, so we have some number. It is greater than, so I've got a number here. Got a number. It's greater than 8 times 5 to the third power. But it's less than 2 times 8 to the third. and the sum of the digits equals 11. Okay, here's the key to this. 5 times 5, 5 to the third is 125. So 5 times 5 is 25. 5 times 25 is 125. Okay, I think that's right. 25 times 5. 5 times 5 is 25. 5 times 2 is 10. Yes, 125. Okay. Now then, we've got 8 times that number. 8 times 5 is 40. Carry the 4. 8 times 2 is 16. 16 plus 4 is 20. 8 times 2 is 16 plus 4 is 28 times, so I'm carrying a 2 here. 8 times 1 is 8, plus 2 is 10. So that is 1,000. So that number is 1,000, and it's less than some number that's less than 2 times 8 to the third. Well, 8 times 8 is 64. 64 times 8. 8 times 4 is 32. 8 times 6, 48. We had this one earlier, didn't we? 512. Now that's multiplied times 2. 2 times 2 is 4. 2 times 1 is 2. 2 times 5 is 10. So 1024. 1024. Now then, it says the sum of the digits equal 11. So it's saying I have some number. These have 4 digits. This has 4 digits. This is going to have 4 digits. But the number has to be in between less than 1,000 or greater than 1,000, less than 1,024. So what does that mean? This number is going to be 1,001, 1,002, 1,003, and so on. But the first 2 digits in all of these numbers is going to be a 1, 0. Well, if they're saying the sum of the digits equals 11, so it's saying this digit plus this digit plus this one equals 11. So since these have to be 1, 0, I mean, it can't be 1, 1. It'd be great, you know, that number's over here, 1, 1, 0, 0, or whatever. So it's 1, 0. So it's saying these 2 digits have to sum up to be 10. 10 plus 1 gives me the 11 that they're asking about. So you could, if you wanted to, say 1004, well, that equals 5. Okay, 1005, that equals 6. Well, I need to get on around here, don't I? So 1010, well, that equals 2. 1011, that equals 3. 1012, that equals 4. 1015, let's go there. 5, 6, 7, oh, that equals 7. 1018, look at that one. 8, 9, 10, we're getting close. 1019. 9 plus 1 is 11. So this is a 1 and a 9. And that number is greater than 1,000. It's 1,019, which is less than 1024. So this number is 1019. Okay, this was estimations. And then we used an estimation on this 150 in this one. So it was good to use less than, greater than, looking at exponents and solving some problems along the way. Okay. All right, I have a little saying at the bottom here. Of course, you know, why are we doing this? Because together we're trying to build a better tomorrow and do that through math. But I want you every day to tell yourself something. I want, when you wake up, to tell yourself, today is the day that you make a difference. Of course, when you're telling yourself, today is the day I make a difference. And how am I going to do that? I'm going to seize the day. I'm going to jump in there and be positive and study and work hard and try to grow my mind so that I can build a better tomorrow through math. Okay? All right, seize the day, and then this is all for now, and we'll talk to you next time. Thanks.